Today, we are talking about something that could completely upend how we find information, specifically the tiny, crucial details buried deep inside scientific papers. It's a new system called PaperRegister, and it's pretty darn cool. So, if you've ever had to do any kind of research, you know this feeling, right? That frustration. You're hunting for one specific piece of information, a single data point, a tiny detail about a method, and it's lost somewhere in a 20-page PDF. It honestly feels impossible, like you're searching for a needle in a digital haystack. And look, this isn't some made-up example. This is a real-world query from the research paper itself. It is ridiculously specific. It's not just asking about a general topic, it's asking about the nitty-gritty operational details. This is the exact kind of thing that makes our current search tools just throw up their hands and say, nope, can't help you. And that, right there, is what researchers call the needle in a haystack problem. You know, for decades, search engines have gotten amazing at finding general stuff. But the second you need to get really, really specific, they just fall apart. Okay, so here's the core of the problem. Traditional search engines, they basically just read the abstract. You know, that little summary at the top of the paper. But let's be real. The juicy details, the stuff you actually need, is almost never in the abstract. PaperRegister is built differently from the ground up. It's designed to read and understand the entire paper, every single word, from the title all the way to the last appendix. So how in the world does it do that? Well, this is where the genius comes in. Instead of just grabbing that little summary, PaperRegister builds a whole new kind of digital library for every single paper. It's a library with a way, way smarter design. You see, the old way, that's an abstract-based index. It's kind of like a library catalog that only lists the back cover blurb of a book. Sure, it tells you the genre, maybe the main character, but it has absolutely no clue what happens in Chapter 12. It's a super shallow map, and that's its fatal flaw. And now, here's the game changer. It's called the hierarchical index tree. Think of it like a super detailed, multi-level map of the entire paper. It's not just a flat list of keywords. No, it's a branching tree that organizes everything from the big, broad ideas at the top all the way down to the most tiny, specific facts at the bottom. So at the very top level of this map, you've got the general method. Then you drill down the layer and you find the implementation details. And you go even deeper, bam, you're at the ultra-specific training operation, which is exactly what that complicated query from the beginning was looking for. This hierarchy is the magic trick that lets it answer any question at any level of detail. And now this whole thing sounds really complex, right? You might be thinking, does someone have to build these crazy detailed maps by hand for every paper? The answer, thankfully, is no. And this is the first huge innovation. All of that heavy lifting is done automatically in what's called the offline process, long before you ever type a single search query. So here's how it works. First, a big, large language model acts like this incredibly dedicated research assistant. It reads the whole paper, front to back, and pulls out all the finest grained details, the real nuts and bolts. Then, and this is the really clever part, it works backwards, or bottom up. It takes all those tiny details and starts summarizing and grouping them into bigger and bigger categories, building that entire hierarchical tree, all on its own. It's brilliant. Okay, so we've got this incredible, super organized library, but a library isn't much good if the librarian is slow, right? This brings us to the second major innovation here, the online process. This is what kicks into gear the second you hit search. The hero of this part of the story is a small but mighty AI called the View Recognizer. It has one job and one job only: to look at your search query and instantly figure out its depth. It knows if you're asking a big, general question that lives at the top of the tree, or if you're digging for some tiny, specific fact way down at the bottom. So how does this little AI get so smart and so fast? Well, it starts as a small, efficient model. Then it goes through this really cool two-stage training. First, they teach it the basic language of science. But the second stage, that's the secret sauce. It uses reinforcement learning, basically rewarding the AI specifically for getting better and better at pinpointing the exact level of detail a query is asking for. It's this special training that makes it both razor-sharp accurate and incredible fast. All right, so the theory is fantastic. You've got a smart library built by one AI and a lightning-fast librarian AI to find what you need. But does it actually work? I mean, really work in the real world? Let's look at the proof. First things first, speed, because nobody's going to use a tool that takes forever. They tested PaperRegister against other advanced search methods, and the results are just jaw-dropping. Look at this. Other systems took over 20, even 30 seconds to come back with an answer. PaperRegister, 2.5 seconds.
I mean, come on. That isn't just a little bit better. It is more than 8 times faster. For you, the user, that's the difference between a tool that feels amazing and intuitive and one that just feels broken. This is a massive, massive leap in efficiency.
But okay, what about accuracy? Especially on those really tough, specific searches we started with. Well, when they tested finding these fine-grained details, the old abstract-only method got it right about 58% of the time. PaperRegister, a whopping 81% of the time. That is a staggering 22.6 percentage point jump in performance. And it's happening precisely where it matters most, on the hardest queries, the ones where the old systems completely fall flat. This isn't just a theory anymore. This proves the whole idea of the hierarchical index is just a flat-out better solution. So we've established it's way faster and way more accurate. But what does this actually mean for science, for research, for all of us? Let's zoom out and look at the big picture here. You know, the implications are just enormous. When a researcher can find exactly what they need in seconds instead of days, it speeds up the entire pace of scientific discovery. Think about all the crucial little details that are currently just locked away, hidden inside millions of papers. This system unlocks them. It makes research more efficient for everybody, and it builds a foundation for even more powerful AI tools that can start connecting the dots in ways we can't even imagine yet. Which kind of leaves us with one final big question. For centuries, our ability to find knowledge has always been the bottleneck to creating new knowledge. So what happens when that bottleneck just vanishes? If we can instantly pull any detail from the entire library of human scientific thought, what breakthroughs are coming next?